Hello, my name is Natalie Rakowski, and I am a student at Georgia Institute of Technology. This is a test wrapper problem video focusing on problem 1 of test 3, and the subjects are magnetism, current, and the loop and node rules. So here's a problem. A circuit is assembled that contains a long bulb and a round bulb, as shown, with 4 compasses placed underneath the wires. We're looking down at the circuit. When the long bulb is unscrewed, the compass on the left, next to the battery, deflects 15 degrees, and when the long bulb is screwed back in and the round bulb is unscrewed, the compass on the left deflects 4 degrees. With both bulbs screwed into their sockets, draw the orientations of the needle of each compass, and write the compass deflection beside the compass. So first I'm going to go over the loop and node rules. So the node rule says the current into the node is equal to the current out of the node, as seen in this diagram. The loop rule says that the potential difference of any round trip path in a circuit is equal to 0, because potential difference is kind of like work. Determining magnetism with a compass. This compass, as we see here, the compass is below the wire, and north points to the right. So that means that the magnetism of Earth points to the right, and the current points to the right, and if you use the right-hand rule, you would find that because the current points to the right, the magnetism of the wire points up. And so therefore, you draw the needle as the magnitude between the wire and the magnetism of the wire and the magnetism of Earth. And theta is the degree between the wire and the compass needle. Now in this video, or this problem, we will be kind of making an assumption. So usually when you deal with magnetism and compass needle degrees, you would say that the magnetism of the wire is equal to magnetism of Earth times tangent theta. Since Bmag is about equal to current, we're going to be saying that current is equal to the magnetism of Earth times tangent of theta. So the first step in solving this problem is that we're going to write the loop equations. The first two loop equations I have here are for when the long bulb is alone with the 2 batteries, and for when the round bulb is alone with the 2 batteries. And the final is when both the long bulb and the round bulb are screwed in. Now the funny thing is that because of the loop rule, the equations for the first 2 are actually also the equations for the last one. As you see here, this is a loop, this is a loop, this right here is the same loop as the first one, and this right here is the same loop as the second one. So the next thing we're going to do is we're going to solve for the resistance of the long light bulb and the resistance of the round light bulb. So if we solve for this, as seen here, we find that the resistance of the long light bulb is 2 EMF, the 2 batteries, divided by the current of the long bulb. And the resistance of the round bulb is equal to 2 EMF divided by the current of the round bulb. Next, we use these to solve for the different currents with the node rule. So now we're going to take these resistances and plug them back in to the 2 original loop equations and find that I2, I beside the second compass, is equal to I long, and I3 is equal to I round. Also, we find that I1 is equal to I of long plus I of round. Next, we will use this to determine the different thetas between each compass. Since I2 is equal to IL, we find that theta 2 is equal to 4 degrees as well. And since I3 is equal to I round, we find that theta 3 is equal to 15 degrees. And since I1 is equal to I long plus I round, we find that I1 is equal to 18.67 degrees. And because along this line the same current flows as right here, both this compass and this compass are deflected 18.7 degrees. And now we'll have to draw the direction of the needle for each compass. As discussed before, we use the right-hand rule to determine the magnetism of the wire, the direction of the magnetism of the wire, and then draw the needles. As seen here, I did it for the first compass. And now we fill them in for the rest of the compasses. And now here's our solution. Thank you for watching my video and have a wonderful day.